Sections 9 and 10 in Chapter 8 essentially deal with Lewis structures, but they also talk about the localized electron bonding model, which is essentially a term that you need to be familiar with. Before I define it, I just want to talk a little bit about models and the kind of the point of a model. Models are attempts to explain how nature operates on a microscopic level based on experiences in the macroscopic world. It's important to remember that a model does not equal reality. They are oversimplifications and therefore often wrong. They typically become more complicated and they are modified the longer they've been around. And it's really important that we understand the underlying assumptions in a model so that we don't misuse it. Now, you might say, well, what the heck is a point? None of that sounded very positive. But it is important to remember that when a model is wrong, we often learn much more than when it's right. So, the localized electron model says that a molecule is composed of atoms that are bound together by sharing pairs of electrons using the atomic orbitals of bound atoms. We can look at those pairs and assuming that they are localized on a particular atom or space between two atoms. There can be lone pairs, which are pairs of electrons localized on an atom, and there can also be bonding pairs, which are pairs of electrons found in the space between atoms. The localized electron model does a couple of things. It describes to us the valence electron arrangement, and this is the Lewis structure that we'll talk about in a second. It also gives us information on the geometry, sort of the shape of a molecule, and that's using the VSEPR model, which we will get to. And finally, it describes the orbital types used by atoms to share electrons or hold lone pairs. Now, more in detail on Lewis structures, as I mentioned on the previous slide, it shows us the valence electrons are arranged among atoms in a molecule, and basically all relates to the idea that a compound is stable in a noble gas electron configuration. Now, there's a couple of rules that you need to keep in mind when you're creating Lewis structures. The first is the duet rule, and that applies to hydrogen. Hydrogen forms stable molecules when it shares two electrons. So here we have two hydrogen atoms sharing electrons, thus filling their valence shell and being happy. I guess I use the term happy a lot, which probably doesn't apply, so let's say stable. Not happy, but maybe they are happy, I don't know. Anyway, octet rule. Elements form stable molecules when they are surrounded by 8 electrons. You can have a single covalent bond in which the two atoms are sharing one pair of electrons, or you can have a double covalent bond where they are sharing 2 pairs of electrons. You can even have a triple covalent bond where two atoms are sharing 3 pairs of electrons. There are some general guidelines for writing Lewis structures. The first thing you do is sum up the valence electrons of all the atoms. Then you take a pair of electrons and form a bond between each pair of bound atoms. And then you remember that because atoms usually have noble gas configurations, you will need to arrange the remaining electrons in order to satisfy the octet rule, or the duet rule if we're working with hydrogen. So let's look at an example. First step, sum up the valence electrons of all the atoms. You're going to need a periodic table, and here we would see we have 2 hydrogen atoms. They each have 1 electron, and we have 6 electrons on the oxygen, which makes 8 total. And remember, we're talking about only the valence electrons here. And then we're going to use a pair of electrons to form a bond between each pair of bound atoms. So we've done that. And remember, there were 8 electrons we had to deal with, and now we've used 4. 2 between one of the hydrogens and the oxygen, and 2 between the other hydrogen and the oxygen. Then we would need to arrange the remaining electrons around to satisfy the octet rule, or the duet rule for using oxygen. So because we had 4 electrons left and hydrogens valence shell was already full, we're going to put the remaining 4 electrons on oxygen. The next thing is to count and see how many electrons you have on oxygen. So you've got the 4 electrons, the lone pairs, and then they're also sharing 4 between the hydrogens. So oxygen has 8 electrons in its valence shell, thus satisfying the octet rule. We can try that with other compounds as well. So why don't you try to do the other 2 on the slide. Pause it if you're not done. I'll put them up. And there they are. Remembering that hydrogen only needs 2 electrons and everything else needs 8 for the most part. Give you a chance to try to work on a couple more practices. Pause it here, try to do these 3. And some more to work on. We are going to stop it here. If you have questions about these, I'm not putting the answers up because I want you to actually try them, but we will talk about these 6 in class.